Hey guys, I'm the math professor, Kyle Martin. In this video, we're going to go over another 3-variable system of equations. I know my students have been asking for another one of these, and if you are one of my students, this one may or may not be on the quiz tomorrow, so I'd keep watching if I were you. Also, like and subscribe, all right? If you haven't done that yet, what are you doing, okay? Anyway, this one, x plus y plus z equals 3, 3x minus 2y minus z equals negative 4, x plus y minus z equals negative 1. All right, so our game plan here, we got to try to eliminate one variable from all three of our equations, okay? And then we can turn that into a system of equation with 2 variables after that. So I'm looking here at one that might be easy, and I think probably this top one, it's a positive z. These two are negative z's. So right away, those are going to eliminate. All right, so I'll save you a little bit of trouble here. I'll write those out. Okay, so again, what I did right there is I took my top one and my second one, I wrote them next to each other, and we'll eliminate those. The z's are going to cancel, which is good. All right, and then I also took my top one and my bottom one, put those next to each other. Again, the z's are going to cancel. You have to get the same variable to eliminate from all three at the very beginning in order to start one of these systems of equations in 3-variable problems. All right, so once these eliminate in my first and second one, that's going to leave me with 4x, and then let's see, minus y equals negative 1. All right, and then down here, I'm going to have just 2x plus 2y equals 2. Okay, and so then I'm going to take these two and I'll put them up here, and it's a system of equations in 2 variables now. Let's do that. Okay, so all I did right there is I took this and put it up there, and I put this up there. I like to see them kind of next to each other. That helps me out when I do these problems. Let's see. So I'm going to probably multiply my top one times 2, because then I'd have a negative 2y and a positive 2y, which I know can eliminate. Again, I'll do that for you. Okay, so again there I multiplied the top one times 2, and I wrote it down here, and then I just copied this one down and put it next to each other so that the y's, it looks like, are going to cancel. And when I do that here, 8x plus 2x is 10x equals, and then 2 minus 2, of course, is 0. So 10 times what is 0? X has to be 0. All right, so we got one of them. I'll circle that. Now, the only thing I can plug this x back into is one of my equations that has x and only one other number. I cannot put it back into my originals yet because it has an x, y, and z for all 3 of those. All right, so what I have to do is take my x equals 0 and probably put it back into one of these 2 red ones. Let's see, I think top one looks just fine. We'll put it in there. So now 4 times, instead of x, we can say 0 minus y equals negative 1. Well, 4 times 0 is 0, that cancels. So negative y equals negative 1, which means positive y equals positive 1. So y equals 1, okay? So we got x, we got y. Now I need to plug both of those, x and y, into any of my 2 originals, and I think the easiest one to do that is probably the top one. If I were to replace the x as 0, the y as 1, and add these together, 0 plus 1 plus what, call it z, equals 3. Well, I need this to be a 2. 0 plus 1 plus 2 would equal 3. So I think z has to equal 2. All right, and then remember, you write your answer as an x, y, z ordered triple. And so here my x is 0, my y is 1, and my z is 2. And that is the answer to this system of equations in 3 variables.